Alright, in this tutorial we will be working with what's called circle packing, and we'll be creating the image on the right of the screen in the Rhino viewport where you see the three penguins, and we'll be using circles to map an image. This was used last year, 2 years ago, as a digital fabrication project, I believe in the Palmer, where they water jet cutted steel to cut the lion symbol, and it was presented in the window of Palmer. So we'll show you how to do that in this Grasshopper definition. So let's start with a blank screen. We'll come down here and we'll just start entirely blank. And what we're going to need, I'll turn this off actually. And I'll just work off of this file here. You'll want to build this from scratch, or you could open up the file on the server folder, but I think it's easier to learn if you're doing it from scratch. So what we're going to need is two series components, and you'll find the series component under sets, sequence, and then series down here. So you'll just click one of those and drop that onto the canvas, and you're going to need two of those and two sliders. So what the series component does is it's a counter, so it will make a series of numbers. When you put a default one on here, we'll just go back up and grab a default series. We'll put a panel. So the default series is going to make a series of number from 0 to 10, starting at 0 and going 10 numbers. And what it's asking for is the first number in the series, which in this case is 0, the step size, which in this case is 1, so it's just going 0, 1, 2, 3, 4. You can change that to 0.5, and it will end up being 0, 0.5, 1, 1.5, 2, 2.5, and so on. And then the count is an integer, and how many values do you want in the series? So how many numbers do you want to create? In this case, in the default, we're going to have 10. So for our series components, we want to use 0 as the start number, 1 as the step size, and we'll put a slider into our integer. In this case, we're setting our maximum to 50. So if you remember how to do that, to grab a slider, you go to params, special number slider, and drop two of those onto the canvas, or one, and then copy and paste it. And then double click on the word slider to bring up the dialog box. And this dialog box is going to ask how do you want to set it up. So we're going to do number slider or integer slider with a min of 0 and a max of 50, and then we're going to set our value to 50 for both of them so they're identical. And then what you're going to get when you hook these up and you preview them is for some reason I can't preview this one. Oh, that's right, because the series has nothing to preview because it's just a list of numbers. My mistake. So from the series we're going to grab a point component, because what we need to do with these numbers is create points. So where it says 0, 1, 2, 3, 4, the reason why we have 2 is so that we can create 0, 0, and then 1, 1, and then 2, 2, and we're going to be creating points in the x and the y direction at all of those numbers. So the point component is up here under vector, point xyz. I'll drop one of those onto the canvas, and the first series is your x component, the second series is your y component, and then what you're going to see is this. You should have this diagonal line. It would seem that this would be correct, but what we actually want is an array of 50 points all the way across here and all the way across here, so we get a big square. What this is doing is just running the first point against the first point, second against the second, and it's not cross-referencing them. The way that we change this, if you right-click on point, and you pull up the editing box for that, where it says shortest list, longest list, and cross-reference, Right now it's running the longest list, so once it gets to the end of the first number, it's done. What cross-reference will do is it will reference every point with every other point. So you'll get 0, 0, and then you'll get 1, 1, and 1, 1 in both directions. So if we change that to cross-reference, what you're going to get is this giant grid of points, highlighting green. Again, if yours isn't highlighting in green, when you click on it, you can come up here to the preview settings, and then just click and drag one of these green balls onto the selected area, and then you can change this to a little bit transparent. Okay, so once you have the series and the point, what we need to grab is, pull this out of the way for now, we need to grab a bounds component, and this is 2D bounds. So what this means is, we'll go up and go ahead and grab it a while. Under math, domain, bounds 2D, make sure you grab the 2D bounds and not the top bounds, because 2D bounds, as it says, creates a numeric two-dimensional domain which encompasses a list of coordinates. So what this is essentially doing is putting a bounding box around the amount of points that we have, and it's giving you the location of the furthest point and the closest point, and then it's telling you like how far that step is. So when we grab that, what we want to do is flatten these points. That's what this little down arrow means. So to flatten the points, it means you're taking the list, and instead of them being their own individual points, you're making one giant list out of all 2,500 points. So you right click on C, and you'll come down here to flatten, and you'll click on flatten, and then it's essential on this one that we have a panel component to read this, and we can rename our panel bounds. So the panel is going to show us our inputs that we need to use in our image sampler, and the image sampler is whatever image you would like to show with the circle packing. So this grid points I have down here is just a simple point container. We talked about in the first tutorial this set of geometry and primitive, how these are just containers. So this just contains all of the number of points so that it's easier to move around in your script. So we'll just come up here and under geometry and grab a point container and call it grid points, and we're going to plug all the points right into there. So you could unpreview this point and preview this point, and it's the identical geometry. So we'll unpreview both of those. The next thing that we're going to need is, ignore that stuff at the bottom, we're going to need an image sampler and another panel to make sure that our values are correct. So what you want to do is under special, go to image sampler and put that on the canvas, and you'll end up with this red box with the big exclamation point in the middle. The reason it has the big exclamation point is because it isn't running any information, there's no input, so it says I'm failing. The way that it needs to collect data is you have to load an image, so what we're going to do is double click right on the center of it. It's going to pull up this image sampler settings dialog box, and it's important that we load any type of picture that we want. So to load the picture, you have to come down here to file path, and you'll click on the three little dots, and it's going to pull up just a simple finder window, and you can search. We'll just go to my computer, we'll go see. Actually, I'm not sure if I have any photos on here. Come here to images. Okay. So this is just a random, I believe this is a Frank Gehry building in a paper that I was writing for leakage in some of his buildings. So you can grab any photo that you want. It doesn't have to be grayscale like it is here, because we're going to turn that into grayscale anyway. And where these channels are, what this means is this is what it's going to output. So in this case, it's going to output RGBA colors. And then you can go over and it'll output red channels, green channels, blue channels, the alpha channel, color hue, color saturation, and color brightness. So in our case, we want to use color brightness all the way to the right. And we also want to interpolate. It says if checked, samples in between exact pixels will be blocked. And interpolate just is doing just that. It's saying, like, take the sample next to it and reference in between so that it can calculate the right numbers. And we also make sure we want to click on color brightness because we want just the black and white values of this to use as our radius for our circles. Probably the most important part about the image sampler is where it says X domain and Y domain. And the reason why this is important is because this has to match whatever our bounds came out to be. So if you were to come back and change your grid of points, then your bounds will also change. So what we want to do is match the U to the X and the V to the Y. So where it says 0.0 to 49.0, we want to put 0.0 to 49.0. And the same thing in the Y direction. It's once again, because we have a box, it's also 49.0. So what this will do is it will sample the exact amount of pixels in here as we have points. So each pixel is aligned to a point. And then you can click preview and it'll show you in the image sampler. And then you can hit OK. Okay, so from here, down here I loaded a default image of penguins. It'll be a little bit easier to see when we sample the image. So from there you want to use output data. So you see what this is giving you is decimal values, because these are the brightness values. If I were to come in here and change this, you don't have to follow this. If I change it to RGB, it's going to fail because I don't have this, I don't have this picture on my desktop, but I think it referenced it in. See, what it's going to give me is RGB values. These RGB values aren't going to work because we need a decimal number to create radii for our circles. So I'll just come back in here. This is helpful in the second part when we want to color it. Go back to this. It'll tell me that it's going to fail. Okay, we're back to decimals. From these decimals out of our panel component, and again, the panel component is up here under special panel. We can plug, you're going to need a multiplication component, because what this is right here is radius values, but because the values are so small, and we're working in inches right now, if you say you want 0.3 inches a radii, it's going to be too small to see in our Rhino window. And if you're interested in laser cutting it, you can mess with the size of the radii and how small your circles are and what your sample size is. But in this case, we need to multiply these values to get bigger radii. So this multiplication function here is under math, operators, multiplication. And it's just as simple as, 8th grade algebra. It's just you're multiplying A by B. So whatever you put in A, which in this case we're going to click and drag our output data into A. And our B, we're going to make a slider. And the settings for this one are going to be 0 to 100. And I just set my numeric value at 23. So what we have here, if we copy this panel and we take it to the outside of this, you're going to see that all these values have been multiplied by 23. So once they're all multiplied by 23, it may seem a little counterintuitive, but we have to divide those numbers. And in this case, we made the numbers too large. And we're actually going to bring them down a little bit. What this is doing is, it may seem like a total waste of a step, and you're probably wondering why we're doing this at all. But the reason we multiply and then divide is because we're creating a threshold. So the threshold is how far you want to push it. So how far the circle next to it affects the circle before it. And if we leave the values as they are identical, then we don't have enough manipulation of it. So what this is, we can manipulate both the multiplication function and the division function, and it will give us a much finer level of detail and a much finer level of change in our numbers and in our radii. So it's not a useless step. Okay, so now what we need to do is just create circles. And the circle component, there's 3 different ones. Under curve, primitive, you have a circle, which is create a circle defined by a base plane and a radius. Circle 3-point creates a circle defined by 3 points. CNR, which is center, normal, and radius. And circle fit, and then there's also tangent, 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 which is tangent to 3 curves. But we're going to use circle, which is center, normal, radius. So drop that onto your canvas. And I just renamed mine flat circles because we're going to make the circles have height in a little bit. So what we need to do is define, okay, what is our center point? And our center point is going to come way back here from our grid points component, because we want to create a circle at each one of all of these grid points. So what you're going to do is pull that, drag it all the way over here, and plug that into the center point of our circles. And our radius is what we just did. This is our division after the multiplication. Plug that into R for the radius. N is a normal vector, and that just, if you're familiar with Maya or 3D Max, or even in Rhino and 3D printing, you know that your normals always have to be facing the same direction. So in this case, we're just having our normals face straight up, which is just a base plane to create them. So then if you preview this, what you'll get is the picture of the penguins, and it's been recreated in circles inside of Rhino, which is kind of cool because you can then export this to the laser cutter and make it as a screen for a window. You'll see the light coming through, and the shadows coming through will be the image of, in this case, penguins. So if you want to stop there, go ahead and stop there. What we're going to do is we're going to move these now. So this is a very simple component. We just want to take those values and copy this multiplication function. And we want to change this slider that we had set from 0 to 100 to 0 to 10. And in this case I used 5 digits because we want a pretty high degree of variability. I set the numeric value to 0 for now, so the heights are at 0. And what I did was I need to move this. So we want to take all these circles and move them vertical. So what do we need? We need a move component, which is under transform, Euclidean, move. And we also need a vector for which direction it's going to go. So in this case I went to vector, vector, unit z, because we just want to move them in the z direction or straight up. And then I plugged this multiplication function, which is a series of, right now, 2,500 zeros. Plug that into f as the factor, and then plug that z into t. And what you're going to get, if we unhide the circles, is right now in a perspective view, everything is going to be perfectly flat. But what we want to do is pull this height slider. You can rename it height slider. It makes it a little easier to understand. You're just going to pull this to the right, and what's going to happen is these aren't all going to move the same. See, they're all going to move at different heights based on the darkness and the lightness of the image. So I think this is really interesting. So if you look at a perfect side view, what you're going to get is a whole bunch of crazy looking circles, but what you get from sort of an axonometric or an isometric view is really a 3D image of the penguins built in circles. And then you can play with this height as much as you want. You can take them really high, or you could bring them all the way back down. So just a simple manipulation of that makes a whole another dimension of movement. So what we did there, just to recap, is we copied this multiplication function, we brought it down, we changed the slider from 0 to 100 to 0 to 10, and made it a 5-digit rounding. Used a unit z, plug the rounding number into the factor of the unit z, plug the z into the move component where it asks for t, which is translation vector. And the reason why this is 2500 values of vectors is because this is 2500 circles. So the first vector will always meet with the first circle. The second vector will always meet with the second circle. So they always match up. So this number has to match this number identically. So the third and final thing that we're going to do in this script is we're going to color these. And what we want to do is just copy and paste that penguin picture right below it. And again, you can highlight them both and organize them with these arrows. And then this time we want to grab another panel, double click on this picture, and we want to change from color brightness over to RGBA colors so that we get an output of RGB colors. Keeps telling me it's failing. And a really helpful component is called preview, or also under params, special, it is the custom preview down here. So all this is asking for is G, what is the geometry that you want to shade or want to color in the preview. So in this case, it's our moved circles, so that it'll stay with all of our 3D circles even if we move them to different heights. And it says, what shade do you want to color them? So this has to be RGB values or CMYK values, some type of color value. So what we can do is plug all 2500 of these color values into S,